The Cerna Geometry Unit 4 review number 1. We'll look at a lot of problems in this video. I'm starting with the number 11. I'm going to go to 11, 12, 14, 16, 17, 18. There's a lot I'm going to see in this one. I'm skipping around, but there's quite a few. Now I'm going to start with number 11, where it says, Laura says all rhombi are parallelograms. Marianne says all parallelograms are rhombi. Who is incorrect and why are they incorrect? I'm going to start with rhombi. It goes rhombi are parallelograms, but instead of actually writing parallelograms, I'm going to write what the definition is of parallelograms. And remember, parallelograms were quadrilaterals where opposite sides were parallel. Now, when you think about your rhombus shape, all your rhombi, I'm going to draw one over here. Remember that the rhombus had all congruent sides, but since it did follow after the parallelogram, it did also have parallel sides. So when you look at this statement, the way I wrote it, rhombi are opposite sides are parallel. That sounds kind of weird. That is a true statement because rhombi do have parallel sides, two pairs of parallel sides. Now Marianne says parallelograms are rhombi. Parallelograms. I'm going to say instead of are have. Now the thing that makes rhombi or a rhombus unique is that it has 4 congruent sides. So I say parallelograms have 4 congruent sides. Now is that true? If I draw a parallelogram, does it automatically have 4 congruent sides no matter what parallelogram I draw? Well, I can draw a parallelogram like this. Remember, the only thing that parallelogram needs to be a parallelogram is these 2 pairs of parallel sides. But this top and bottom are definitely longer than the left and the right. So this does not work for that order. So the ones that did work was rhombi parallelograms, which means Laura is correct. Marianne, though, said the opposite, which did not work. So it says, who is incorrect and why? Marianne is incorrect. Not all parallelograms have 4 congruent sides. Number 12, in triangle TUV, side segment TU is congruent to side TV, and the measure of angle V equals 65 degrees. Find and label the measures of all the angles. Now with these 2 sides being congruent, that means that we have an isosceles triangle. Yes, the base angle theorem says that when we have the isosceles triangle, that these 2 base angles are congruent. In other words, angle U is also equal to 65 degrees, so we got that one. Now to get angle T, remember that triangle sum theorem tells us all 3 angles in the triangle add up to 180. So I can now take the 65s and add those together. I get 130, and then I'm going to subtract that from the triangle sum, which is 180, and I get 50 degrees. And now I've got all 3 angles. Number 14. Given R is the midpoint of XY and WZ. And that should be an R. So R is in the middle here. That is the midpoint of XY and WZ. A, mark the diagram using any postulates or theorems that apply. So if it's the midpoint, remember midpoint means it's directly in the middle. So if it's the midpoint of XY, that means XR and YR are not congruent. That also means that WR and RZ are not congruent. The other thing we can mark is that at R we have vertical angles. We have a pair of vertical angles there. Now I can't mark these congruent. I don't know that anything is parallel. I don't know that these are the same length. That's all I can mark at this point. Part B, which theorem or postulate can be used to prove that these 2 triangles are congruent? And there's a little typo again. It's XVW, this is now R. YVZ, that's R. When we look at just one triangle, I've got side from these 2 dashes, angle in between, side from the single dash. In other words, side angle side works for number 14. Number 16. Given the figure shown below, list all the missing angles. Now they've got angles 1, 2, and 3 that we have to find. Angle 1 hopefully is the easiest angle to find because 1 and this angle across are vertical angles, which means they're equal. So angle 1 is 47 degrees. Now to get angle 3, I look at this bottom shape. I've got a triangle. All triangles, remember triangle sum theorem, sum of the three angles in the triangle is 180. 47 plus 64, I get 111 degrees. 180 minus 111 degrees, I get 69 degrees. So angle 3 is 69 degrees. The last one I need is angle 2, which is part of this top triangle. And I'm going to use the same triangle sum theorem again. I'm going to take 63, I'm going to add 47, I'm going to get 110 degrees. I'm going to take 180, I'm going to subtract that 110, I get 70. So angle 2 is 70 degrees. And now I've got all three missing angles in number 16. Number 17, given the figure math, M-A-T-H, shown below, use the number 2, 3, 4, 5 for the sides and segments of the diagonals to create a rhombus. Now, the one thing that's tricky is it's not drawn to scale. It doesn't look like a rhombus. It actually looks more like a parallelogram. But the whole point is knowing what to do with the numbers and knowing the properties of the rhombus. Now, what I'm going to do is I'm going to first start with the sides on the outside. Remember that the rhombus, the definition is that it is a quadrilateral with 4 congruent sides. So I'm going to take those sides and I'm going to label one number on all 4 because, again, they should all be congruent. So I'm just going to use the 5. I'm going to take the 5, 5, 5, 5, and now I've got all 4 sides outside congruent. Now I've got the inside. Now I don't have to use 2, 3, and 4. I don't have to use all those numbers that are left. I just really need to choose which ones I'm going to need. Now the rhombus, the other properties in the rhombus were that the diagonals were perpendicular and that they bisect each other. The diagonals in the rhombus are not equal to each other. You always have one longer diagonal and one shorter diagonal. So what I'm going to do is I'm going to choose, looks like this, kind of looks like the longer one.
Attention teachers, Belmont Flores and Mrs. Foster, please call extension 6031.
Don't they realize I'm making videos? Sheesh. So now, the 4, I'm going to put that here on ET, which means that it is exactly the same as this one. In the rhombus, again, these diagonals cut each other in half. So this distance matches this one, which means that's now 4. So I've used the 5 and the 4. Now I've got the other diagonal to label. I can use either one. It doesn't actually matter as long as the thing that matters is that this is equal to this. So if I just, I'm going to get rid of the 2. I'm going to use the 3, which means this has to also be 3. And now I've got everything labeled. I've got the diagonals labeled, and I've got the sides labeled. Last one, number 18. Use the diagram below to answer the following questions. Write an equation to solve for x. Part A. There are, let's see, 1, 2, 3. You could actually write probably 3 different equations for this problem to solve for x. You could use triangle sum theorem, where these 3 make a long equation and add up to 180. You could ignore that. You could look at these 2 and see it's a linear pair. This plus this equals 180. You could be ambitious and use exterior angle theorem, where you could use this exterior angle, the one outside, equals these 2 remote interiors added together. Any of those equations should get you the same thing for x. The very first one I mentioned was triangle sum, so I'm going to start with 4x plus 2x minus 24 plus 3x plus 6 equals 180. I'm going to combine like terms. 4 plus 2 plus 3 is 9x. Negative 24 plus 6 is minus 18. I'm going to add the 18 to both sides. You get 198. I'm going to divide by 9. I'm going to get 22. 22? Yeah. 22. Now, just to check, you don't have to do this, but I'm going to just show the example with exterior angle theorem. Now, that means I'm going to start with my exterior angle, the 5x minus 2. I'm going to put it equal to these 2 remote interior angles. This is the one we don't need. We do not need that one when we're dealing with the exterior angle theorem. 5x minus 2 equals 4x plus the other remote interior angle, which is 2x minus 24. Combined terms, 6x minus 24, 5x minus 2. Subtract the 5x, I get x on this side, negative 2 minus 24. Plus 24, plus 24. And notice when you get negative 2 plus 24, you're going to get x equals 22 again. So that works. The two different equations gave that same answer. Now it says part B, find the measure of the exterior angle. And I'm taking that 22 and I'm going to go to that exterior angle, 5 times x, plug that 22 in. I get 110 minus 2, I get 108 degrees. There is my exterior angle in number 18.